All right, guys, so this problem says a force Fx equal to minus 5x squared plus 7x. Hey, guys, acts on a particle. How much work does the force do on the particle as it moves from uh, x equal to 2 meters to x equal to 5 meters? All right, so you saw that the work done by a variable force is this integral. Okay, and it's from the x initial to x final point. Okay, so let's do that integral. And the force is minus 5x squared plus 7x dx. By the way, so let's spend a second to look at the units. This is a force. This function is a force, so that the units of force are newtons. What are the units? What are the units of this number? That 5. I'm sorry. So let's make sure we understand this. That has to have newtons per meter square. Do you guys understand that? Because this will have units of meter square, that meter square will cancel that, and this term will have units of newtons. This term has units of newton per meter. The meter there will cancel that, and each term will have units of newtons. Yep. Yes? I'm sorry? I guess we need a brighter bulb here. Okay, so now, so this integral is um, minus 5x cubed by 3 plus 7x squared by 2. Okay, and that's the work done. Okay, now, okay, so also since this function is integrable, this force is the derivative of this function. Okay, and if the force is a derivative of a function, that function is the potential energy function, except the negative of that function is the potential energy function. Okay, so you saw that F is related to the potential energy like that. Okay, so U must be equal to 5/3 x cubed minus 7/2 x squared plus C if you want. Okay, because the derivative of a constant is 0. Okay, so that's the potential energy function, and that's the integration constant that you see. Okay, when you do an indefinite integral. Okay, so we'll get to that in a second. So that's U, the potential energy function. Okay. So let me clean this up. C. Okay. Now the work done is you have to evaluate it from x initial is 2 meters to 5 meters. So the work done is minus 5/3 5 cubed minus 2 cubed plus 7/2 5 square minus 2 square. Okay. Well, that thing didn't download the. All right, so this works out to, let's add a page below. Okay, so work is this is minus 5/3, 125 minus 8 plus 7/2, 25 minus 4. Okay, and so this is this works out to minus 105, 21.5 joules. Okay. And now you saw that this was the potential energy function, and part B says picking a convenient reference point of the potential energy to be 0 at x equal to infinity. So actually that's a typo. That should be x equal to 0. See, at x equal to infinity, no matter what constant you put, if you can't pick a finite constant such that this goes to 0. As x goes to infinity, this will go to infinity. This function would go to infinity. Okay, so that's it. We'll fix that to x equal to 0. So now for part B, here is ux 5/3 x cubed minus 7/2 x squared plus c. So if you want ux to be 0 at x equal to 0, that just implies c equal to 0. Okay. So your potential energy function is 5/3 x cubed minus 7/2 x squared. And that was the function I plotted. Okay. So all right, well, let me stop this recording and then I'll show you that function. So I'll show you that potential. Actually, so the potential energy, that function looks like so. Okay. So, well, we would not be interested in this part. So this is the part we'd be interested in. A realistic system would have that kind of potential. Okay. So that's what we'll be looking at. All right.